So Noah asked me to do the show a couple of months ago, and when he invited me to share a fact, he asked if I had any fun gut-brain axis stories, and I said yes. He also said, and I quote, "Hell yeah, fecal transplants are regrettably very funny."
I told you that in confidence.
It's out there for the world to see now, friend. So I took that as a green light for my fact tonight, which I have titled "Of Mice and Moods," you'll see why. Or what you will also see is much more appropriate, "A Tale of Two Shitties." So we're going to talk about fecal microbial transfer. This is a procedure in which gut bacteria from a healthy gut are transferred into an unhealthy gut, ostensibly to replace the microbiome there and make it healthier, just like our donor. So this has been really useful for a lot of different things, especially things like C. difficile infections, which can be, which are notorious for being making you really sick and being notoriously hard to treat. There are actually only a couple of antibiotics that treat it, literally two. And even when those work, the infection often comes back, so they can be really recurrent. So this has been, FMT has been really useful for people who have been failed by antibiotics when they have C. difficile. And there we go. Yeah. So there are a lot of really healthy effects for these C. difficile infections when people are getting this FMT. But interestingly, there are other general health improvements that people report, and some of those are related to mental health. So, depression, autism, bipolar disorder. A couple of studies have really shown that there's some mental health improvements in people who have gotten FMT. So, FMT is good for a healthy gut, but does it actually do something for your brain? So a lot of people have asked this, have been studying this, and one of the best examples here is a 2011 study from Burchick and colleagues. And what they wanted to do was to see if changing the gut microbiome of different mice could affect their brain chemistry and behavior. So what they did was they took two different strains of mice, one called BALB-C and another called Swiss Webster. And the important thing about these mice is that they actually differ on their anxiety phenotypes. So BALB-C mice are a little bit more anxious, Swiss Webster are a little bit less anxious compared to one another. And there are a lot of different reasons that behavioral difference could be there. But I actually like to think that it's because it's maybe genetics, right? I think it's better explained by the fact that BALB-C were originally derived in New York, and Swiss Webster come from Switzerland, so they're hanging out in a chalet or shit. And that just makes a lot more sense to me.
Checks out.
All right, so you may be asking, how do you measure anxiety in a mouse? So what they did was something called the step-down test, and I'm going to prepare you. This is a little bit unpleasant for the mouse, but we really take care of mice when we have them in the lab. They use something called the step-down test, and in this test, you put the mouse on a little platform, and that platform is above a electrified grid. And when the mouse steps down on it, they get a little foot shock. It's mild, and they quickly learn to avoid that because it's not very nice. Then the next day, you put the mouse back on that platform, and you measure how long it takes them to step down on that grid. And the idea is that if the mouse is more anxious, it'll take a longer time to step down on the grid because it remembers getting shocked. And if it's less anxious or more confident, then it will take a little bit less time to step down on that grid. So to measure the effects of the microbiome on this anxiety phenotype, what they did is actually swap the gut microbes from one strain of mouse to another. So they gave the Swiss mice the BALB-C microbiota, and they actually saw that when they swapped them, the behavior swapped too. So they made the Swiss mice more anxious by giving them BALB-C microbes, and they made the BALB-C less anxious by giving them Swiss microbes. So it seems like something was transferred just by transferring these microbes. So I think also that could be explained by the fact that New Yorkers know to stay away from electrified shit. So you tell me. So another really good example of a study that has looked at this association between FMT and behavior is a study in rats by Kelly and colleagues in 2016. And what they did is they made germ-free rats by giving them a shit ton of antibiotics to disrupt their gut microbiome. And then they found either healthy, non-depressed donors or people with depression, and they took a stool sample from those volunteers, and they transferred them into their rats. And then they measured their behavior. So in this case, what they did is they used another behavioral assay called an open field test. And here, when you put a mouse or a rat into an open field, they tend to spend a lot of time around the edge of that field because they get nervous in open spaces, and
Makes sense. They've seen Bambi, so.
They've seen Bambi, so they stay close to the edge. And you just measure where the mouse goes and how much time they spend there. So in this case, they measured how much time their rats, sorry, not mice, spent in the center of the open field. And again, they saw, or just like that other study, they saw that transferring the microbes from the controls made them a little bit more confident. They spent more time in the center. And giving them microbes from depressed people, they spent a little bit less time in the center of the open field, so they're looking a little bit more anxious. They also did something called a sucrose preference test, which measures something called anhedonia, which is the absence of pleasure from things that are normally enjoyable. So in this test, they give the rat a choice between water and a sucrose solution. And if they're feeling more anxious or depressed-like behavior, showing more depressed-like behavior, then they might drink less of that sucrose solution than the water. And so in this case, they saw something really similar to that last test. If they gave the rats microbes from people with depression, they drank less of that sucrose. So it seems like they were kind of anhedonic and sad.
So everything sucks. I don't need Gatorade.
I don't want the sucrose, yeah.
It's just not gonna make it any better.
When I'm sad, I feel like I want more chocolate.
I like a dilute solution of sucrose at 1%.
Yeah, I mean, to each their own.
You don't like that?
I mean, I would if I tried it, for
I've
sure.
had LaCroix.
That's
Whoa, shots
0.01%. That's 0.01%, actually.
One of those little bottles.
So what they actually saw is that these features of depression from people could actually be transmissible through their gut microbiomes. It turns out that there is actually a connection between brain health and gut health. But where is that coming from? The answer probably lies in something called the gut-brain axis, which is a network of interactions between your brain, your nervous system, and your gut, and the gut microbes that live in your gut as well. So your gut is a really important organ, right? So it makes sense that this is going to be affecting your overall health. It actually has its own nervous system called the enteric nervous system that's composed of hundreds of millions of neurons, which actually can operate semi-independently of the central nervous system. So if you cut it off from the brain and spinal cord, your digestion keeps going. But normally they're actually talking to each other quite a bit, and so there are a lot of effects that you can see of the gut on the brain. So if you've ever, sorry.
You're familiar with my morning routine.
This is a point.
Jump scare.
So you've probably experienced this if you have, and this was what popped up first on my Google search for taking antibiotics. So I couldn't not share this with you.
Come on.
So if you've ever taken antibiotics and felt a little bit off, maybe your stomach hurts, maybe you're fatigued, or maybe you have a little bit of brain fog, you've probably experienced some of the consequences of your gut-brain axis at work. And that's because those antibiotics actually wipe out not just the bacteria that are causing whatever infection that you're trying to treat, they actually kill a lot of the ecosystem that's normally there and keeping you all regulated and regular and all sorts of stuff. So this throwing off of the gut microbiome has actually been associated with a lot of different neurological outcomes. Alzheimer's disease, Parkinson's, depression and stress, and neurodevelopmental disorders. Fecal microbial transfers have actually become so much more common and so purportedly effective that the FDA actually regulates this like it does a drug. So your doctor can actually prescribe to you a couple of like drugs that are based on fecal microbes, and they have really fun inserts.
That's actually, speaking of inserts, that's how they put it up there.
It works in tandem. It's like
I heard
it's
somebody go, Jesus.
I mean, I've heard of
correct.
a coffee enema before, but
Hey. I love the little toilet hiding in the background.
oh yeah.
And they become like fecal microbial transfer has actually become so popular that there are stool banks. And if you, as a person, wanted to donate your stool, you can do that for money. So if you need a little bit of
how
extra cash,
much
Flushing
money?
this all down the drain?
Wait, but you have to be really
Like-
mentally healthy, right?
Like, okay, as a poor grad student, how much money though?
okay,
I think
but
it's-
you're
I
a
think
grad
it's like-
student. You're anxious. They don't want your poop.
I'm so anxious.
so donate plasma, donate stool.
Yeah.
So that's what I got for you. I wanted to leave you with just maybe a moral of the story and maybe another book title. So if you give a mouse a dookie, you might learn something about the brain.